Good morning, dear students. My name is Ferhan Mazher, and today is 30th December 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O levels physics, and we are working on alternative to practical. We call it paper 4. Today, we have selected May-June 2018 4-2 paper. This ATP paper, alternative to practical, belongs from the zone 2. And let's start this paper. So May-June 2018, 4-2 paper. The time allowed for this paper is 1 hour. Okay, so let's start this paper. Okay, so the first question coming up on your screen, you can see that question. And it says, a student measures the resistance of a lamp when there are different currents in the lamp. She sets up the circuit shown in the figure 4.1. So here we have a power supply, here we have rheostat, or we call it the variable resistor. Its resistance can be changed. Here we have a lamp, here we have an ammeter. On the figure 1.1, draw the symbol for a voltmeter connected to measure the potential difference V across the lamp. Okay, so we have to connect a voltmeter here, which will be able to measure the potential difference across the lamp. So what we will do, I will put a voltmeter here parallel to this lamp. Let me show you. So here you can see on your screen with the red color, I have shown a voltmeter which is connected parallel to the lamp. So this voltmeter will be able to measure the potential difference across the lamp. Okay, so the next thing they are asking is, she adjusts the variable resistor until she obtains the readings on the voltmeter scale and the ammeter scale shown in the figure. Okay, so she said the question is read and record the table of the figure 1.3, the potential difference V in volts and the current I. So here we have a table, we have to voltmeter reading, here ammeter reading, the current, here is the resistance, okay? Here are the conditions, the brightness of the lamp, it will be bright or it will be dim, okay? So what was the B part? She adjusts the variable resistor until she, okay. So what's the reading on the voltmeter right now? That's the question. What is the reading on the voltmeter right now? This is the voltmeter. So this is 0, this is 1, this is 2, this is 3. So it will be 1.5 here, and this will be 1.6. So here I will write 1.6 volt. Now, what's the reading on the ammeter? Be very careful. This is 0, this is 0.2, 0.4, 0.6, 0.81. So if this is 0.2, this will be 0.1. This will be 0.12, 0.14, 0.16, and 1.18. So I said 1. This will be 0.1, this will be 0.12, 0.14, 0.16, 0.18. So this is between 0.16 and 0.18. So it will be something like 0.16 and 0.17. The reading will be 0.17. Okay. So these will be the readings which you will enter here. So enter those readings here, and then you can find out the resistance also. Let me show you the table. Before he says, the student adjusts the variable resistor and measures the new values of V and I. Her values are shown in the table, figure 1.3. The lamp is dimmer. The lamp is dimmer, okay. Use the equation R is equals to V by I to calculate the resistance R of the lamp for both settings of the variable resistor. Record your answer in the table to an appropriate number of significant figures. Okay. So we can find the R value. The formula is given V by I. So I can calculate the R value for these two values, and I can also calculate the R value for these two values. Let me show you. Okay, so here we go. So this was 1.6, this was 0.17, and I can calculate the R value. The R value will be V by I, and 1.6 divided by 0.17. Enter this in your calculator and you will get 9.41. In the same way, I can find the second R value, and that the V value is 0.83 divided by 0.11, and you will get 7.55. So when the lamp is bright, the resistance is 9.41. This is the resistance of the filament. And when the lamp is dim, the resistance is 7.15. So let's check what's the next part. We are done with the C part. The student thinks that because the same lamp is used throughout the experiment, its resistance is constant. State whether the student's results confirm this. Justify your answer by referring to the results. Okay, if you look at the results, we just have two sets of values, and in both the sets of values, the R value is different. In the first set of values, the R value is 9.41. In first conditions, the R value is 9.41. In the second conditions, when the lamps are dim, the lamp is dim, the R value is 7.55. So the value of the R is not constant. So our table is not telling us this. So the values are different from each other. The R values, they are not constant, they are changing. Okay. The values are not same. So he thinks that the same lamp is used throughout the experiment. Its resistance is constant. Its resistance is not constant. If you look at the values of the R, they are 9.41 and 7.55. So these values are not close to each other. So they are far apart from each other. So we think that the student's argument is not right. Okay. Then their question is, let's have a look at that. Another student says that the resistance of a lamp filament increases when it gets hot. State giving a reason whether the observation confirms this. Okay, so they think that when the filament, the student says that the resistance of a lamp increases when it gets hot. Yes, that is possible. Look at our question. Okay, so we look at this table. Look at this table. When the lamp is bright, and when the lamp is bright, it means that it feels that it will be hot, and the resistance is 9.41. So it looks like that when the lamp is hot, it's bright, its temperature will be higher. The resistance is 9.41, which is higher as compared to the other reading. When the lamp is dim, its temperature will be less as compared when the lamp is bright. And the resistance is also less. You can see 7.55. So that argument looks good. Result shows when the lamp is brighter, it is more hot, and its resistance is also higher. Okay. So we think that when the lamp is hot, it's more brighter, and we know that from our table, from the values in the table, that its resistance is also higher. In the D part, you are supposed to mention the table also, okay? So I just showed you the table, but I have not entered those values into my answer, but he said that enter your values into your, refer the values in the table in your answer, okay? So that is D and E part. So, okay, the next part is, there will be a different question, okay? So we are almost done with this question. So let's have a check. Question number 2 then starts. Okay, so let's have a look at the marking scheme first of all. So the marking scheme is showing up on your screen. It says, here we go. So the correct symbol and parallel connection with the lamp, the V is 1.6 volts, the I is 0.170 ampere, 9.4 ohm or 7.5 ohm. No values too different, too far apart, beyond the limit of experimental accuracy. The difference is more than 10%. So the result shows that the lamps has a greater resistance when brighter, yes. So that is question number 1. Hopefully you understand that how this question has been solved. Okay, so let's move to the next question. The next question coming up on your screen is: a student investigates the reflection of light by a plane mirror. She places the mirror vertically on a sheet of paper. She uses a pencil to mark the position of the plane mirror with a straight line and labels the line XY. And she removes the mirror and draws a normal at the center of the line and labels the normal AC. She labels the point where the normal crosses the mirror with the letter B. So here they're talking about. So this is the mirror, this is the normal AC, and when the normal crosses the mirror, that point is named as B. The sheet of paper is shown in the figure 2.1. So here is the observer. Let me reduce the size so you can see the whole thing. So here you have the observer. This is the lamp and this is the normal. And here they have put 2 pins, P3 and P4. Okay. So what their question is? A ray of light is incident on the mirror at the point B with an angle of incidence of 40 degrees. On the figure 2.1, draw a line 10 centimeter long from B to the left of the normal and below the mirror to represent the incident ray. Label the other end of the line as D. Okay, it's a 2-mark question. So this is the normal and this is the right side of the normal. This is the left side of the normal. So they said on the left side, draw the incident ray. That incident ray should make 90-degree angle, 40-degree angle, I think he said. Yeah, 40-degree angle with the normal, and that line should be 10 centimeter long. And the other end, the one end will be B, the other end will be called as D. So it's a 2-mark question. So let me show you how I have done this. Okay. So on your screen, you can see that I have placed a protector like this, and its zeros are balanced on this normal, and this cross here is on the point B, and this is the left side of the normal, and the incident angle will make 40-degree angle. So this is 0 and 10, 20, 30, and 40. Put a dot here, then I will remove this protector. So here you can see I have removed the protector. This dot, I will join it with this point B, and the line should be 10 centimeter long. The line should be how much long? It should be up till this point, 10 centimeter long. And you can see here I have drawn a line DB, which is 10 centimeter long, and it is making 40-degree angle with the normal. So the angle of incidence here is 40 degree. Okay, so this is the part they have asked us to do. Okay, now let's see what's the next thing they are asking. Then they say that the B part, the student replaces the mirror. She places a pin P1 close to the point B on the line DB and places a second pin P2 at the point D. She views the image of the P1 and P2 in the mirror from the direction indicated by the I in the figure 2.1. And she places 2 pins P3 and P4 on the paper so that the P3 and the P4 and the images of the P1 and P2 when viewed by E are in a straight line. The position P3 and P4 are shown in the figure 2.1. On the figure 2.1, draw a line joining the position P3 and P4. Continue your line until it reaches the mirror. Okay. So what we have to do basically, the P3 and the P4, they have already shown. You will join P3 and P4 with each other and until you reach the B point. Here you have already drawn the incident ray. So let me show you. So here you can see I have joined P3 and the P4, the incident ray has already been drawn. This is P3 and P4. Here we have P1, P2. These are the 2 pins which we have put on the line DB. So that is what they are asking us to do. Okay. So now the next part. He says, measure the angle of reflection R. Okay. So I want to measure the angle of reflection R. So if you want to measure the angle of reflection R, you see this is how you will put your protector. And you can see the zero of the protector is on this normal, both the zeros. And the crosshair is on the point B. Then I will count 10, 20, 30, 40. It's a little more than 40. Okay, remember, this is like 41 something or 40, you can see. Ideally, they should be 40. So I have written here 41, but the actual angle is 40. I have written here 40. Angle of incidence is 40. The angle of reflection is supposed to be 40, but actually it is 41. It's not like, okay, 40. But we have written here 40. It's approximately 40, but it looks like that is 41. Okay, so measure the angle of reflection R, that's 40. And let's see what else they are asking us to do. Then he says measure the angle of reflection, that is 41 actually. You can write 41, I have written 40. State one precaution that the student should take when positioning the pins to obtain an accurate value for the R. You see the pins, they should be vertical to the paper. The horizontal board on which you have put that paper, and where you are inserting those pins on, the pins must be vertical. And when you align, you should not look at the head of the pins. You should always be looking at the bottom of the pins. So the bottom of the pins should be aligned. Okay. So he is asking to write one precaution. Okay. Okay. So that's question number 2. It's almost over. So pins should be vertical. They were asking you to write one precaution, which will make your experiment more accurate. And we have written one precaution here. Pins should be vertical. Okay. So that's the question number 2. Okay. So have a look at the marking scheme. Question number 2. The marking scheme is coming up on your screen, and you can see that it says line of length 10 centimeter and with its ends labeled D. 1 mark for this. Angle of incidence 40 degree to the left of the normal and below the mirror. We are done with that. Line passing through P3 and P4 and reaching the mirror. We are done with this. He says 42 degree. They think 42 degree. The diagram, the photo I have taken, here it's showing 41 degree. I have written 40 degree, but you are supposed to write the exact angle. Achha, so pins vertical, and the precautions are the pins should be vertical to the horizontal table, and align by viewing bases of the pins. You should align the bases of the pins, not the heads of the pins. Pins should be far apart. The pins, the P1 and P2, they should be more than 5 centimeters apart. And the pin 3 and pin 4, they should also be more than 5 centimeters apart. So these are the precautions, and we are done with the question number. We are done with the question number, you can say question number 2. Okay, so let's move to the next part. And the next question coming up on your screen is question number 3. Okay, so he says a student measures the least pressure that a rectangular wooden block exerts on a table. He places the wooden block on a sheet of paper with its largest surface touching the paper. He uses a pencil to draw the outline of the wooden block on the paper. Figure 3.1 shows the outline of the block drawn on the paper. So this is that wooden block. You can see if you have a rectangular wooden block, it will have 8 faces. So the face which should be touching the ground should be that whose area is largest. Then the pressure exerted will be least. Okay, so figure 3.1 shows the outline of the block drawn on the paper. He says, take the measurements, underline this word. It's very important to understand this word. Take measurements from the block. He says, take the measurement from the block to the nearest 0.1 centimeter and calculate the area of its largest area. So with the help of a scale, measure how much is this length and how much is this width. Just length multiply width, that will give you the area of this block, which is in contact with the ground. So I can use this, I have to do this calculation. So with the help of scale, I put the scale here and I will measure how much is the length, how much is the width. So let me show you. So So take measurements from the block. So the length is 5 centimeter, the width is 2.3 centimeter, and the area, you know how we calculate the area of a rectangle? Length multiplied width is the formula. So 5 multiplied 2.3, so it will be 11.5 centimeter square. I have written here centimeter square. Don't write this because this centimeter square is already written here. So don't write it here. So it's kind of, you are not supposed to, not this. The pen, so don't write this, okay? This centimeter square is already written here. So this is the question number 3 and this A part. And keep. Okay, now the next part. Then they say, here we have, the student finds the weight W of the block with a Newton meter. So this is a Newton meter. Here you have hung that wooden block. So this extension will tell you how much is the weight of this wooden block. Write down the weight of the block here. So from here I can read what is the block's weight. So let me show you. So we have made it. So actually I'm extending it so you can read it. So that is that, okay. So what I will do, I will try to check what's the reading. So this is 1 here, okay. So if that's 1, so it will be, here we have 1, it will be 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. Okay. So this is how much? This is 0.1 and 0.1 and 4. Yeah. This is 0.14. So the weight is 0.14. Okay. So the reading is 0.14. I think 0.14 Newton. So let me check. Okay. So the write down the weight of the block, that will be 0.14 Newton. So that's how you write it. 0.14 Newton. Okay, so the next part they're asking is use the equation. That's the part which we have done. Wait. So use the equation. Density is equals, this is called rho. This is for the density. Density is equals to weight divided by, no, this is not, sorry, this is pressure. Use the equation, pressure is equals to weight divided by area. So to calculate the pressure P due to the weight of the block on the table. So weight divided by area, so you see Newton per centimeter square. So the area will be in the centimeter square. So weight you from here and divided by the area. Area is that area which you just calculated. So you will be able to find out this answers, okay? So let me show you. So the pressure will be equal to weight divided by area, and it will be 0.14 Newton divided by 11.5 centimeter square. So when you enter this in your calculator, the answer will be 0.012 Newton per centimeter square. 0.012 Newton per centimeter square. So that will be the pressure. Okay. So that's the question number 3. Okay. Then the D part is, he says another student says that the actual pressure due to the weight of the block on the table is greater than the value calculated in the C part. So just one practical reason for this. You see, when you draw the face on the page, so with the ballpoint, with the pencil, you have drawn that. So that outline is actually larger. You see, if you imagine, that outline is 100%. I mean, that is definitely the length and the width which you have drawn is definitely greater than the actual length and width. Because when you draw on the paper, the line is outside that rectangular box whose face you are trying to trace on the paper. So when you draw that line, the actual length and width on the paper is more than the actual length of the rectangular box, length and width. So when you calculated the area, so obviously that area is larger than the actual area. So that's why the pressure will be actually more than the pressure you just calculated. So there can be other reasons also. So let me show you my answer, question number 3. Okay. So the outline drawn on the paper is larger than the actual areas, because when you draw the outline of a block, the line obviously will be little outside. Okay. So obviously, you will get uh, a shape whose length and width will be little more than the actual rectangular face. Okay, so that is question number 3 and its D part. So the question number 3 is done. So let's have a look at the marking scheme. So on your screen, the marking scheme of the question number 3 is showing. The A part is 5 and 2.3, either way around for length and width. And the area will be 11.5 centimeters square. And he says except 12 also. And the weight is 0.14 Newton. And that answer is also right. Then he says it will be, the area will be, it says that the pressure will be 0.012 Newton per centimeter square. Okay, so let me see. Our answer is the same. Yeah, 0.012. Okay, so our answer is right. Okay, so then he says the outline traced is larger than the actual area of the block. So that was the question number 3. The whole question's answers marking scheme is showing up on your screen. You can pause the video and you can take your time with this marking scheme. To check your answers yourself and compare your answers with the marking scheme is very, very important. Okay, so let's move to the next question. He says a student measures the density of copper using a balancing method. He sets up the apparatus as shown in the figure 4.1. So you can see here we have a pivot here, and it's that 100 centimeter rule, and the pivot is at the 60 centimeter mark. Here is a mass M. Here is a copper cylinder, and we don't know how much is distant from this end. And if once I know this R1, I will be able to tell what's this distance from the pivot. I can tell why very easily, because I know that the mass M center is on the 90-degree mark, 90 centimeter mark, and the pivot is 60. So 90 minus 60, it will be 30. So Y will be 30 centimeter. X, I can tell once I know what is the value of the R1. Okay, he says she places a pivot under 60 centimeter mark on the meter rule. The position of the pivot is not changed during the experiment. She places a 150 gram mass M on the meter rule. So that its center is at the 90 centimeter mark of the rule as shown in the figure 4.1. Okay. She places a copper cylinder on the rule and adjusts its position until the rule is just balanced. Figure 4.2 shows the position of the cylinder at the balance. Okay, so its center is exactly at 90. Its center is here, they have shown. So its center is approximately at 9 point something, 9.4, 9.5, or 9.6. So copper. So the figure 4.2 viewed from above, the distance from the left-hand end of the meter rule to the center of the base of the cylinder is R1. So this is R1. So I can tell this, whatever, this is something 9.4, 9.5 something. Take readings from the figure 4.2 to find R1. Record your value of R1 in the table of figure 4.3. Show your working. So table 4.3 is also here somewhere. So here I have to note down what is the X value and what is the Y value. Okay. So R1 value will be noted here. And from then I can use these formulas and I can tell what the value of X, what's the value of the Y. R1 value is 9 point something. Okay. So I will then complete this table. So let me show you my answers. Okay. So question number. Okay. So this is that reading. So I think that the reading is 9.4 centimeter. This reading is 9.4 centimeter. Okay. So I will write here 9.4 centimeter. So 60 minus R1, X will be 60 minus R1, and that will be 60 minus 1.4. And that will be, so it will 9.4, sorry. So it will be 50.6 and R2 minus 60. And that is 90 minus 60, and that will be 30 centimeter. Hopefully you understand these formulas. The R2 value, R1 value is coming from that diagram. Okay. So then what they say? We are done with this part. Now the B part is, he says, the student repeats the procedure by moving the mass M and placing its center on the 85, and then 80, then 75 and 70 centimeter marks of the meter rule. Her results are shown in the table of the figure. So what they're doing, basically they're moving the body M. They put it on different location, and then they balance that by moving the cylinder also. And then they calculate the values of the R1, R2, X, which is 60 minus R1, and Y, which is R2 minus 60. And that table is already filled. Okay. So then the question is, this is the figure 4.1, and hopefully you can see that. Record in table of the figure 4.3, the missing values of X and Y. On the grid in the figure 4.4, plot a graph of Y. On the y-axis, the y value I will take on the y-axis, and the x values on against the x-axis. Start with the axis of the origin, draw the straight line of the best fit, determine the gradient of your line, show your working, and indicate on your graph the values. Okay, so this is that table. The reading here is 1.4, sorry, 9.4, and this is the values. Okay, so now we have to draw the grid. So the y values I have taken on the y-axis, and the x values I have taken on the x-axis. So 10, 20, 30, 40, 50. Here we have 10, 20, 30, 40. You see the graph which is given, at least 75% of the area of that graph must be used. Okay, so here I have put those dots of the x value, y values, and you can see these dots. I put those dots here. So then I have to draw the line of best fit. So here I have tried to draw the line of best fit. Okay, so this is the line of best fit. Then they want us to find out the gradient of this. So I have taken these 2 points and I made a triangle here. So this is my rise and this is my run. And you know the gradient is rise by run. So it will be 19.5 divided by 45, and it will be 0.433, rise by run. So this is the gradient of the graph is 0.433. So here you can see I have shown the working also. Determine the gradient of your line, show your working. Okay, so here the gradient is rise by run, that's 19.5 divided by 45, and that will be 0.433. So the gradient of line is 0.433. The mass M in grams of the copper cylinder is given by the equation. So let me read that question first from the question paper. So we are done with the gradient. Then he says the mass M in grams of the copper cylinder is given by the equation. M is equals to 150 multiply the gradient. Whatever is the gradient, you just multiply it with 150, you will get the mass of the copper cylinder. Use this equation to calculate the M to the nearest grams. Okay, so we have done with this. Okay, so you can see here 150 multiply, that's the formula, into the gradient. The gradient is 0.433. So 150 into 0.433, that will be 64.95, which is, when you round it off, it will be 65 grams. So that mass M is 65. That copper cylinder is basically 65 grams. Okay. So then they ask you another question. Let me see what the question is. Question 4 is continued on page number 12. Okay. The student, he says that it's too small. The student uses a measuring cylinder to find the volume V of the copper cylinder. She pours 50 centimeter cube of the water into the measuring cylinder. She lowers the copper cylinder gently into the measuring cylinder. She put that copper cylinder into that water measuring cylinder. So the level of the water will go up. And he says figure 4.5 shows the measuring cylinder containing the copper cylinder. Use the information in the figure 4.5 to calculate the volume V of the copper cylinder. Okay, so initial V1 reading was 50. When you have put the copper inside, now the reading is something like 57, I think, centimeter cube. So when you subtract 57 minus 50, you get the volume of the cylinder. So he says, calculate the volume. It's a 2-mark question. So then he says, find the density using this formula. Okay, so we'll find the density also. So let me increase the size. Okay, so the V will be 57 minus 50, and that will be 7. So it means that the volume of the copper cylinder is 7 centimeter cube. The mass is 65 grams, and we know the volume. We know the mass. I can find the density. Density is mass divided by volume, 65 divided by 7. It will be 9.3 grams per centimeter cube. 9.3 grams per centimeter cube. Hopefully you understand. Okay, so the next part they are asking is, I think it's the last part, the value for the density of the copper obtained in the D differs slightly from the correct values. State one practical reason for this difference. You see, we have used a measuring cylinder here to find the volume of the copper. So there is possibility then when you have put that cylinder, copper cylinder into that measuring cylinder, the water might have splashed and some water might have got out of that measuring cylinder. That can has changed the volume of the water, and that will change your results. Okay, so that can be one reason. There can be many other. Another very different problem is that it's difficult because you see, you told that this is the center of the cylinder, which is on that scale. To exactly tell where is the center of the cylinder is a bit difficult thing. Okay, so let me, so we are done with this, and by this question we have reached the end of this paper. So let me show you question number 4 is coming up. The question number 4A part was some indication of the working shown either on the diagram or in the space provided. For example, 8.6 centimeter, 10.2 centimeters seen, marked either side of cylinder, line marked in the middle, marked center marked. So the actual value is 9.4 centimeter. Then we have 50.6 and 30.0. Axis labeled quantity and unit, and the axis correct way round. Allow R2 minus 60 centimeter for Y and 60 minus R1 centimeter for X centimeter. Scales linear, not awkward, points plotted accurately to the nearest 1/2 of the square. Best fit line, straight line drawn. Indication on the graph of how data obtained and at least half of the line between the extreme plotted points used. And you see, you can see that our values are in this range. Okay, so then he says 115 to the candidates reading, whatever is the answer here. So in the third part, whatever is the answer. Then 57 centimeter cube and 7 centimeter cube, and that's the volume by using the measuring cylinder. And then candidates, whatever is the fourth answer divided by the C answer. Difficulty in balancing the rule, difficulty in finding the position of the center of the cylinder. Measuring cylinder only reads up to 1 centimeter. So these are the question number 4. Its marking scheme is showing up on your screen. You can pause the video and you can take your time with this marking scheme. So my dear students, today we are done with this paper. Today we have done May, June and 2018 4-2 paper. This is an alternative to practical paper. We call it paper 4. And this paper belongs from the zone 2. I have tried my best to explain you quickly the concepts and the ideas which are being used in this video. If you think that this video is useful to you, if you think that this video is helpful to you, don't forget to subscribe my channel. Also like this video. If you think that this video can help your friends, your class fellows, your juniors, your seniors in understanding ATP more better, share the link of this video onto your Facebook account, into your Instagram, or on the Twitter accounts. So thank you very much, everybody. It's a great pleasure for me to teach you all. So thank you very much, everyone, once again. Have a good day, and God bless you all.